In formal logic, evaluating an argument often requires rephrasing its components. To do this correctly, we must ensure that the new statement has the exact same truth value as the original. This is called logical equivalence. If our starting premise is true, our rephrased version must be true as well. The most direct transformation is a move called conversion. Let's take the E statement, no cats are fish. To convert a statement, you simply swap the positions of the subject and the predicate. Cats and fish trade places, resulting in no fish are cats. This move preserves the meaning of the original sentence, making it a legal move for all E statements, as null as I statements, those that begin with some. However, if you attempt this with an A or O statement, the relationship between the terms changes. In those cases, the truth value of the new statement cannot be guaranteed. We describe the result as undetermined. Obversion is a more versatile tool because it can be applied to all four types of categorical propositions, A, E, I, and O. It achieves equivalence through a two-step process that modifies both the structure and the terms of the sentence. Step 1 is to change the quality of the statement. On the logic square, this means moving horizontally. If we start with our negative E statement, no cats are fish, we move across to the affirmative A form, all cats are. Step 2 is to change the predicate to its complement. In this case, fish becomes non-fish. Our finished obversion is all cats are non-fish. These two statements are equivalent because they describe the same reality from different angles. To say that no cats belong to the class of fish is exactly the same as saying all cats belong to the class of things that are not fish. While obversion works for every statement type, it often results in these non-terms. This makes the logic technically accurate, even if the phrasing feels less natural in everyday speech. The final move is contraposition. This is a two-step transformation that is only legal for A and O statements. Let's apply it to the A statement, all cats are fish. The first step is to swap the subject and predicate, just as we did in conversion. This gives us all fish are cats, but the process isn't finished yet. The second step is to change both terms to their complements. Fish becomes non-fish, and cats becomes non-cats. The logically equivalent result is all non-fish or non-cats. Now, try this yourself with an O statement. Some dogs are not poodles. Pause the video here. Determine if contraposition is legal for this statement type, and if so, perform both steps to find the equivalent form. Contraposition is indeed legal for O statements. First, we swap the terms to get some poodles are not dogs. Then we complement both, resulting in the equivalent, some non-poodles are not non-dogs. To keep these clear, remember that obversion complements only the predicate, while contraposition complements both the subject and the predicate. We can see the importance of these rules by looking at what happens when we apply them incorrectly. If we try to use conversion on an A statement like all dogs are mammals, the result is all mammals are dogs. In reality, we know that while all dogs are mammals, not all mammals are dogs. Because the move was illegal, the truth of the original statement was not carried over to the second. This is why the result is called undetermined. Within the system of logic, we can no longer say whether the new statement is true or false based solely on the original premise. To maintain logical consistency, you must apply the correct move to the correct statement type. This matrix summarizes the legal applications for conversion, obversion, and contraposition. You may want to screenshot this for your notes. By following these 3 transformation rules, you can accurately rephrase categorical propositions and ensure your logical inferences remain valid throughout an argument.